Hi, Algebra 2. Just wanted to take a look at some of the things that we looked at as far as examples in section 4.6 today, which is completing the square. We started off the day in quizzes, and the very first exercise that you had looked like the one that you see on your screen. It says complete the square. It gives you x squared plus 12x plus blank. And so what is it that they're asking of us? So most of us, I think, recognize this as a quadratic trinomial, x squared plus 12x plus something, and this is going to be a constant. And when we talk about a perfect square trinomial, that's a trinomial that we can factor, and both its binomial factors are going to be the same. All right. So we want a number that goes here that makes this a perfect square so that when we factor it, both of these binomial factors are the same. So, well, where does that number come from? Well, let's think for a second. If we were multiplying out these two binomial factors, where did this x squared come from? Well, that was x times x. Okay. And then I did x times whatever this is, and x times whatever this is, added those up and got 12x. Okay. So I added two things together and got 12. Now, there's literally an infinite number of things I could add together and get 12. They're both positive, so that narrows it down a bit. 1 and 11, 2 and 10, 3 and 9, and so forth. But remember what's going on here. This is a perfect square. These numbers are the same. So this plus this equals 12. Another way to think about that is 12 divided by 2 gives me this number. So that's got to be 6, and it's positive 12, so x plus 6, x plus 6. And I can see that this is a perfect square. These factors are the same. So 6 times 6 would give me this last value here, 36. So what it turns out is, as we get asked to work through these types of problems, we've got a pattern that develops. When I'm looking to complete a square, a perfect square trinomial, and I have the first two terms, the squared term and the x term, and I need the constant, where does that come from? So I take my b value, whatever it is, and divide it by 2. That quotient then I'm going to square. So 12 divided by 2 is 6. 6 squared is 36. And another way to think about this is x plus 6, the quantity squared. So what can we do with that then? So we remember that we can solve some quadratic equations by taking the square root of both sides. In their simplest form, when I have x squared equals a number, I take the square root of both sides. So the square root of x squared is going to be x. The square root of 15. Now, this line here, what's going on with this? The absolute value of x is square root of 15. Where does that come from? Well, you remember from Algebra 1 that every real number has two roots. It has a positive root and a negative root, all right? And so the way we write that is when we take the square root of 15, we're going to write positive and negative, plus minus square root 15. So you can write this down, and maybe you already did in class. If x squared equals a, and a is a non-negative real number, then x, square root of x squared, equals plus or minus the square root of a. So let's see what that looks like in practice. So if we were given this equation to solve, 3x squared minus 4 equals 68. Well, I can't really do anything with this to factor it, all right? So let's go ahead and let's isolate the x squared on one side, constant on the other, and see what happens. So add 4, add 4. 3x squared, 68 and 4 is 72. Let's isolate the x squared dividing by 3. 3 divided by 3 is 1, right? So I have x squared equals 72 divided by 3 is 24. All right, well, what did we do up here? We took the square root of both sides, right? So the square root of x squared I know is x. This is going to be positive and negative root, so plus minus square root 24. Now, I can't leave it like this, okay? And we're not going to put this into our calculator. I don't want a decimal number here. I want to simplify this radical using the rules that we've learned. So how does that happen? So we recall that if we can take the radicand and split it into two factors, each of those factors can get its own individual radical sign. So there's a handful of pairs of factors of 24, 1 and 24, 2 and 12, 8 and 3, 4 and 6. Why do I want 4 and 6? Well, we're going to see why in just a second. I want one of these factors to be a perfect square. Because when I split these out into two separate radicals, that perfect square is going to simplify to an integer. Square root of 4 is 2. So I have 2 times the square root of 6. So x equals 2 times square root 6. So here in words, numbers, and then the algebra is that pattern that we saw when we looked at the first example. If I'm trying to complete a square and I have the first two terms, the x squared and the x term, I take the b value, the multiplier on x, the coefficient, divide by 2, square that quotient. So x squared plus 6x, what's this number going to be? Well, I take the 6, divide by 2. 6 divided by 2 is 3. 3 squared is 9. So I have x squared plus 6x plus 9. And now to factor that, two numbers that multiply to make 9, when I add them up, I get 6. Obviously, that's 3 and 3. So if you didn't get a chance to write these down in class, go ahead and pause the video and take a moment to write down these 6 steps that we're going to use to solve a quadratic equation by completing the square. Okay, so you've got them all written down. Let's walk through the process. So we want the constant on one side and the x squared and the x on the other. If we have to, we'll divide through by whatever the coefficient on x squared is, because I want that x squared coefficient to be 1. We'll do that process we just looked at, which is taking the b value, divide by 2, square it, and add that to both sides of the equation. Then we'll factor our new perfect square trinomial as a perfect square, square root both sides, and then we'll solve to find x. So let's walk through that process. Here's an example. So x squared equals 27 minus 6x. I want the 27 by itself, so let's add 6x on both sides. Awesome. So now I need to add something to this side, the left-hand side, to make this a perfect square trinomial. And I'm going to add the same thing to the right-hand side. Remember, anything I do on the left, I have to do on the right. Okay. It's a good habit to get into, to actually draw these blanks, to remind yourself we're adding on both sides until you get in that habit. Well, we just looked at this example, so we know that this value is going to be 9, right? 6 divided by 2, that's 3. 3 squared is 9. And I'm adding 9 here also. So x squared plus 6x plus 9 equals, and then 27 plus 9 is 36. Okay? So, previously when we've been solving quadratics, we want, 0 over here. But for this process, we don't. We want to leave that constant over on that side. So what happens when I factor this? Well, we saw this in our example. Two numbers that multiply to make 9 add up to 6. That's 3 and 3. So this is x plus 3 quantity squared equals 36. Now we take the square root of both sides. Recall that square rooting and raising to the second power are inverse operations. They undo each other. So I'm left with just the radicand, x plus 3. The square root of 36 is 6. So plus and minus 6. So now I have two equations to solve. X plus 3 equals positive 6, and x plus 3 equals negative 6. So minus 3, I get x equals 3, or minus 3, x equals negative 9. Okay, let's look at one more. So here's an example where we need to go ahead and divide to get x squared with a coefficient of 1. So divide by 2, divide by 2, divide by 2. So I get x squared plus 4x equals 6. All right. On the left-hand side, what makes this a perfect square? Whatever that number is, I'm going to add over here also. So my side work, 4 divided by 2 and square it. So that's 2 squared, so that's 4. So this value is going to be 4 and 4 here as well. So x squared plus 4x plus 4 equals 10. Two numbers that multiply together to make 4 and add up to 4. That's 2 and 2. Let's square root both sides. X plus 2 equals plus or minus square root 10. Square root 10 is already as simplified as it can get. Okay, I can't go any further than that. It doesn't have any perfect square factors. So I need to solve for x here. And because this is a radical that's as reduced as it's going to get, I actually don't have to break this up into those two equations that I did a little bit earlier. Like that example, if you get integer answers, you probably could have solved this in an easier way. Like completing the square was a little bit too complicated to do it. You could have factored that one. Okay, but in this case, we couldn't have factored this. So x equals negative 2 plus or minus square root 10. And so that's our solution there. All right, so I did want to take a look at one more example, and this came from the CK12 exercises that we were doing. And so we were taking a quadratic and we were rewriting it in vertex form. So remember what vertex form looks like. Y equals x minus h quantity squared plus k, where hk is our vertex. So if you kind of look at this, it looks a little bit like what we've been doing when we have that, binomial squared and then adding or subtracting a number. So let's start here. Let's go ahead and replace the y with 0. I know this looks a little bit backwards, but it's much easier to move just the 28 over to the left-hand side for our purposes. So 28 equals x squared plus 12x. Well, I need to add something here and here. What makes this a perfect square? 12 divided by 2 and square that. 12 divided by 2 is 6. 6 squared is 36. That's the example that we had way back at the beginning, right, in our quizzes. So this is going to be 36. This is going to be 36. All right, left-hand side. What happens here when we factor this? Well, we've seen already, we know this is x plus 6 quantity squared. 6 times 6 is 36. 6 plus 6 is 12. The left-hand side, these two sum to 64. All right? So now, to fit this pattern, here's my x minus h quantity squared. I need my plus or minus k over here. So let's subtract 64 on both sides. So 0 equals x plus 6 quantity squared minus 64. And then we want to write this as a function. So let's write this y equals x plus 6 quantity squared minus 64. So we just took a standard form equation and rewrote it in vertex form. We're able to identify the vertex of the graph of this parabola. So that's just a real quick rundown on completing the square and converting from standard form to vertex form. Both of those are like the main skills from section 4.6.